Good morning, early birds. Guess what today is? Is that bright enough for you? Is that special enough for you? Do you feel special that I have been here 200 days out of the goodwill of my heart, despite the fact that I am wearing dresses that belong to family members because I can't get my own? Janice and Lisa, you ought to be ashamed of yourselves. But that's not how I really wanted to start day 200. But sometimes I'm a little disappointed in the fact that we are worse off and not better off. Well, that didn't work out very well. On day 200. On day 200, I should not be here in my apartment. I should be revered as teacher of the millennia or millennium. There's two. All right, so we are celebrating day 200 here in the classroom. And I wanted to just show you what we did on day 100 in the classroom there. So day 100, we've cut down our classes. Why have we cut down our classes? This is what I'm saying. Things are really a mess. Why do we cut down our classes? Because I am not getting the positive feedback that this kind of work, hard work, and content deserves. And you know I'm not getting the feedback. I'm sitting here in an apartment instead of in my house on the lake, despite all of the hard work that I put into everything. Who is sitting there not being embarrassed that they stole all my clothes and shoes? Who's not embarrassed by that? And I hope you know that the whole world knows that you did that. I mean, that's gross. You're gross that you would do that. Everything about you is gross. And I'm sorry, Janice Garcia over at GE, Spicer. I have 2 dresses in there in my closet. What's on those dresses too? Is this kind of a Monica Lewinsky thing? I don't know, but we've got to get going, early birds. I worked so hard trying to give you some more. And look at, I know it's such a special day. So that's what we did. 1, 2, 3, 4, 5 classes. I think at one time I had 6. I was also doing Mondays, right? I mean, people have to appreciate this. And I really do think that people do appreciate this. I do see that people do know and appreciate this out there. But I'm still in this apartment and I worked very hard. I'm asking for equal status. I don't mind actually being in an apartment, right? I want to know where my things are and who thinks that they had a right to railroad somebody who's trying to do good work and bring about the American commitment, which is hard work brings about the American dream. I would like to embarrass those people who have lied about the American dream. That's what I would like to do. Fully embarrass the people who have lied about the American dream. But we're at 200. Oh, I know. I just all of a sudden this morning got really frustrated about those things because I was looking for clothes and there's a lot of beautiful dresses I have. I don't even have the dresses that I wore to my son's weddings. How about that? One that I had made for me and pictures taken in and a scarf. It's just not right. It's not right. And anyone who's running around saying she doesn't deserve, well, early birds, there's words on the Bookless classroom I've been using that I've been trying not to use. All of you know that I deserve, and you know I don't get paid for this. I deserve a lot. There's our schedule for today. And look what we have for you. 200 days smarter. 200 days smarter. I am just so happy about this. We are on day number, I can't see that. Put your glasses on, Annette. I know, you know what? I have my black frame ones. Should I wear my blue ones? Those are a little ridiculous. It's a celebration. I have to remind myself it's a celebration. 200 Days Smarter Math Fractions Day 5. I really worked hard on this. I really did. And then also, of course, my computer crashed. Not of course, but it did crash. I know, my hair's a mess. You'd think on day 200, I would have done something about that. I did. You just don't know how it looks on the camera. That's all I got in my defense. That and, yeah, I wish that one part would come down again. Okay, so let's not lose all the excitement of day 200 in the midst of my dark turmoil. Couldn't do that, could we? Ah, look at, she's crazy. She's just crazy. We can't keep any of those clothes and scarves by her. Or shoes. She might trip and fall and hurt herself. No, she can't have that kind of stuff. Danger, danger. She's a handicap. You know who's a handicap? Those people who don't watch a classroom. They're handicapped. They don't believe in mind growth. They don't believe in 200 days smarter. How about that? How about that, early birds? And you have been here since the beginning, even though we're not exactly early birds, right? Oh, I got to get that tooth fixed. I absolutely have to get that tooth fixed. You know that's going to be a treacherous little try and get a tiny thing done by a woman who's a teacher and a smarty pants. Are you a smarty pants? Early birds, are you a smarty pants? I bet you are. If you're here with me and early birds, look at this. Those teeth should look better. They should look better. Okay, let's keep going. Let's not be laughing at hysterical things behind the scenes and somebody thinks you're crazy. Believe it or not, early birds, ta-da! Now, I would go on and on about how this whole thing shut down, and I saved this, and it flattened the whole image, which means I filled in the blanks there. So this is really cool, except for the fact that I can't get back to the old image that I had. And that, my friends, is very disappointing because that was really cool, wasn't it? Being able to move those squares around with the hole in it so that we could be able to see the fractions there. All right, so we were doing, though, we were looking at whether or not these fractions were less than half blue, equal to half red, and more than half yellow. In our final row, we don't have any that are equal to 1/2. Take a look at those, though. We might want to take a look at all of those that are equal to 1/2. 1/2, 6/12, right? So what is half of 12? 6. 7/14. What's half of 14? 7. That means 7 plus 7 equals 14. 4/8. 4/8. So half of 8 is 4, which means 4 plus 4 equals 8. 2/4 is equal to 1/2. 2/4 is equal to 1/2. What is half of 4? 2. 2 plus 2 equals 4. Are we getting this? 5/10. 5/10 is also equal to 1/2. Half of 10 is 5. So if we have 1/2 of 10 pieces, we have 5 pieces, right? Add another 5 and we have the whole thing, 10. 5 plus 5 equals 10. 3/6. That's how we say that, right? 3/6 is also equal to 1/2. What is half of 6? 3, right? So if I had 6 marbles and I gave you half, I would give you 3. If I gave you the whole thing, all the marbles, right? The whole thing, you would have 6 marbles. 3 plus 3 equals 6. I did not save all of the colors in there because I knew that that was easy for us to fill in. But don't forget, what we're talking about then is if we have the whole thing, 3 plus 3 equals 6, then we've got one whole. One whole. Move that puppy back. Then we have one whole. One whole, we could break it into halves, but we can break those halves into eighths, right? Which would be just like what we said. 1, 2, 3, 4 eighths. 4 eighths. Now I know. There we go. Four eighths, right? Equal to 1/2. That's what we have here. 4 eighths. I gotta clear my throat. The next one we have here that is equal to 1 whole is, or half of a whole, is 3/6. So half of a whole can also be 3/6. Where's our 3/6 on here? That equals 1/2. Where's our 3/6? There we go. There's our 3/6, right? Let's add that one. We like that one. What about our 1 equaling 2/4? Where's that on the chart here? 2/4 also equaling 1/2, right? So there's our 2/4 also equaling 1/2. All right, so I think that we have a really good idea of how especially to understand 1/2, right? Especially to understand breaking something into halves. Even if I have 8 marbles, I know how to break that into half, don't I? Now, what we are doing when we are doing that is we are actually doing division. We're actually doing division. So just like we said yesterday, I don't know, did we say it yesterday or was I just working on it yesterday? Let's take a look at this. I think we did say it yesterday. I have to go through the whole thing, but that's okay. But I have it ready to go through the whole thing. There's our whole numbers, right? Those are our whole numbers, 12 whole numbers on our ruler. When we break that in half, we end up with actually 24, don't we? Don't we? When we break 12 into equal spaces, halves, we would have 24 equal spaces there, right? And when we break that down again, we would have 48 equal spaces. And when we would break that down again, we would have 64 equal spaces. All right? If we cut all of those 8 in half, every one of those 8 in half, we would have 16, double the 8. And this is where we begin to have our math, our multiplication, and even our division come into play. Now, I can't remember because I was working on it, but I think I actually did because I remember those, like, where's those? Where are those numbers? All right, so here we have the numerator and the denominator. And there's our denominator. And the numerator tells us how many parts from the whole we're talking about, right? But when we were talking about the numerator and the denominator, see, this is the problem with having to do all this. Yeah, it wasn't there. I have got something that I don't know what happened to that slide. That numerator denominator slide that I showed you guys, but that's okay. All right, let's keep a move on. It could have been here, it could have been there, it could have been anywhere. I had to shut everything down, which means I had to save things pretty quickly. But I think when I was cleaning up this page, I think I accidentally deleted that slide. Okay, no matter, let's keep going. This is what I need. What we're going to do is we're going to end up taking a look at, I think I do have it right there. There we go. All right, so here we've got our numerator and our denominator that we talked about a little bit yesterday. And what I showed you was that when we are doing a math operation, what operation are we doing? What does that mean? And actually, I don't know if I showed you this or not, if I just worked on it. I don't know. I know. I was working this morning too, so it's kind of hard. The teaching gets mixed in with the learning and the doing. So there's our numerator. There's our denominator. What is that? What is that line right there? I don't think I showed you this. I think I did it and planned to show you. What would be that line? That's exactly what we were talking about in our... when we were looking at these 1/2 here. Greater than or less than 1/2. What we were saying was what is half of 4? If we divide 4 by 2, what would we have? 2. If we divided 8 into 2 groups, what would we have? How many marbles would we have in each group? 4. If we divided 6 into 2 groups, how many marbles would be in each group? 3. If we divided 14 into half, into 2 groups, how many marbles would each group have? 7, right? Okay, so what we are doing then is we are actually doing division. What does that mean? Right there, right there. Right there. What does that line mean? What that line means is division. It means division. So that means 1 divided by 4. That's what that means there. That line means 1 divided by 4. I should have done So what math operation are we doing when we work with fractions? We're actually doing division. Okay. All right. Let me see here. I'm going to go ahead and I'm going to keep showing you. Nah, I'm not. Let's keep going with the worksheets before we get into some of the division. We just now know what that line means, right? We know what the line means. So when we're dividing something in half, right, we're talking about dividing 1 into 2 pieces. How much is that? If I divided 1 marble into 2 pieces, how much would you have? A half a marble, wouldn't you? You would have a half a marble, right? All right. So, but you might not just have only 1. You might have 14 marbles. Divide those in half. Divide them into 2 groups is what we're saying. When we say divide something into half, we're saying divide it into 2 groups. When we say divide something into 4 parts, we're dividing that by 4, right? So here's half. The second one there, when we divide something into 3s, we're dividing it into thirds. So we take our pile and we put it into 3 groups. 1/4. When we divide our pile into 1/4, we put it into 4 groups. Or we take our 1 pie and put it into 4 groups. There are a lot of different ways that we use fractions. That's the reason why I have a lot of different examples up here. I know, it gets a little difficult bringing all this great education through entertainment. It gets difficult. Now we are comparing fractions. And these worksheets are so wonderful. This is a worksheet that is from Teachers Pay Teachers. I've got the site down below, the reference down below, so you can find it. These were free sheets and they take us very slowly through comparing fractions, right? We started with the 1/2. And now we're moving on to different fractions other than 1/2, right? Directions. Compare the fractions by comparing the common numerators or the common denominators. Write less than, greater than, or equal to. Now I've got those, greater than, less than, equal to. I've got those. I talk about math families in our classroom in the 70s, like 71, something like that. You can look up, I think I found it under math. And then greater than, less than, I think we're in the classrooms around the classroom day 51 is what I think we did, or 52, 53, right in there for the greater than, less than signs. All right. So I don't want to have to get into that, but you'll get used to those signs even as we're going along right now. All right. So here's what the interesting thing is that they're talking about, and that is comparing the common, actually, I'm going to delete that and I'm going to put this on here. The common numerators or common denominators. All right, what does that mean? That means the same. When we're talking about common, it's the same numerator or the same denominator, right? Okay, so let's go ahead and put that word in there. You know, oh, there we go. All right, I was going to say it's going to come out gigantic, but it didn't. Stop changing it. So that word there, common, means we're looking at the same. So when it has this, we're looking at comparing the same numerators or the same denominators. So in number 1 there, would we have a common numerator or would we have common denominators? In number 1, do we have common numerators or do we have common denominators? Numerators, very good. The top number, that is our numerator, right? The top number there is our numerator. The bottom number is our denominator. So when we are taking a look here at 2 over 4, is that greater than, less than, or equal to 2 over 8? We want to compare the common numerators. The common numerators. If I had 2 pieces out of 4, those are bigger pieces, aren't they? If I had 2 pieces out of 4, would that be greater than, less than, or equal to 2 pieces out of 8? So let's take a look at this right down here. Think it over. Use the rectangle to model 1/4. All right, so 1/4 of that rectangle. And then draw lines to create eighths. Describe the size of fourths compared to eighths. All right. So let's get my line here again. Use the thinner line there. Now I'm going to try and break that in half, just about in half. I think that's pretty good. As best as I can, I'm breaking, though, each one of these, should have started with the first one, into, now we have 8 equal pieces. They have to be 8 equal pieces, right? So I divided each one of those 4 into half to get now 8 equal pieces. And how many of the 8 equal pieces do I have when I have 1/4? 2. 2. But if I have 2/4, how much do I have if I have 2/4? That's 2/4. That's 2/8 or 1/4, right? That's 4 out of 8. We have 4 out of 8 or 2 out of 4. We have half, don't we? Half of that is colored in. But if I have 2/8, I only have 1/4 colored in, don't I? All right? So that's getting our minds to work just a little bit better. Just a little bit better is what we're trying to do. Just to get ourselves to think a little bit better about fractions. Different ways we use them with pies or even with money we're going to talk about in a little bit, right? With marbles we talk about. So let's go ahead then. So what does that mean for 2/4 is what? It's bigger, isn't it? 2/4 is 1/2. 2/8 is 1/4. We just figured that out. So 2/4 is bigger. That means the bigger side of the greater than sign, the bigger sign of the greater than or less than sign, that means greater than. The bigger sign goes towards the bigger amount. The smaller sign goes towards the smaller amount. That's a greater than sign. 2/4 is greater than or more than 2/8. Let's look at the next one. The next one, we also have common numerators, don't we? So, here's number 2. Let's go to number 2. Number 2, we also have common numerators, don't we? So here we've got 5 out of 9 pieces compared to 5 out of 8 pieces. Well, the 9 pieces are cut into smaller pieces, right? Just like these 8 pieces or the 4 pieces are cut into smaller pieces when they're cut into 8 pieces. So if I have 2 out of 9 pieces, those pieces are smaller. I'm sorry, 5 out of 9 pieces. If I have 5 out of 9 pieces, those pieces are smaller. Compared to 5 out of 8 pieces, those pieces are a little bit bigger. So 5 out of 9 pieces watch what we're going to do, is less than 5 out of 8 pieces. 5/9 is less than 5/8. Let's go to number 3. Number 3. Now what do we have in number 3? In number 3, we have a common denominator, don't we? We have a common denominator in number 3. And so that's easy peasy, isn't it? That's easy peasy. If I have 3 out of 8 pieces or 2 out of 8 pieces, which one is more? We've got a cake that's cut into the same number of pieces. So do you want 2 out of 8 pieces or do you want 3 out of 8 pieces of that deliciousness? You want 3 out of 8 pieces because 3 out of 8 pieces is greater than 2 out of 8 pieces. See how easy this stuff is getting for you because you're so smart? Same thing right here. Do you want 4 out of 6 pieces? If you want more of it, do you want 4 out of 6 pieces or 2 out of 6 pieces? That is easy peasy as well. 4 out of 6 pieces is greater than 2 out of 6 pieces because it's more than 2 out of 6 pieces. Okay, now we've got some interesting things going on here. Well, now we've got, again, common numerators again, and you only have one piece. Do you want 1 out of 7 pieces if you're going to only have one piece, and the cake is divided into 7 pieces or 12 pieces? Do you want the 1 out of 7 pieces or do you want the 1 out of 12 pieces? I know, the cake has to be the same size. It has to be the same size, all right? So all we did was take that number 1 and instead of dividing it into 8 pieces, we divided it into 12 pieces, but it's still the same size as that number 1, all right? So whether or not we divided here into 7 pieces or 12 pieces, the one size, the number 1 that we see here is still the same size. No matter if it's divided into 7 pieces or 12 pieces. All right? So we want to understand that. And you get 1 piece. Which one's the bigger piece? The 1 out of 7, of course. The 1 out of 7, of course, is a bigger piece. See how this works? And now I know you know how to do number 6. So I'll let you do number 6 all by yourself. 1 out of 5 or 3 out of 5. Which one is larger? The 1 out of 5 or the 3 out of 5? I forgot to go back to the answers to yesterday. I need to go back to that. Let's take a look at this 1 out of 3 or 1 out of 7. Do you want a pie that's divided into 3 pieces and you get 1, or a pie that's divided into 7 pieces and you get 1? The next one, number 8, we have a common denominator. Do you want 7 pieces out of 16, or do you want 10 pieces out of 16 if you want more? Do you want, in number 9, 2 pieces out of a pie that's divided into 3, or do you want 2 pieces out of a pie that's divided into 12? Number 10, do you want 1 out of 7 pieces, or do you want 2 out of 7 pieces if you want more? Number 11, if you want more, do you want 3 out of 8 pieces or 4 out of 8 pieces? And number 12, if you want more, do you want 1 out of 4 pieces, or do you want 2 out of 4 pieces? If you want more for number 13, do you want 5 out of 8 pieces or 4 out of 8 pieces? For number 14, if you want more, do you want 3 out of 5 pieces or 1 out of 5 pieces? For number 15, if you want more, do you want 3 out of 8 pieces or 6 out of 8 pieces? For number 16, we have common numerators. Do you want 2 pieces out of a pie that's divided into 5? Or do you want 2 pieces out of a pie that's divided into 8 if you want more? Do you want, for number 17, 1 piece out of a cake that's divided into 4 pieces, 4 equal pieces? Or do you want a piece of cake, 1 piece of cake out of a cake that's divided into 7 equal pieces? And number 18, do you want 5 pieces out of a pie that's cut into 7 pieces? Or do you want 5 pieces out of a pie that's cut into 9 pieces? All right, that really gets you started on comparing fractions and also understanding numerators and denominators a little bit better. Let's take a look at the answers to these. 5/7. 5/7. If we look at what is half of 7, what is half of 7? Well, half of 6 is 3. 4 plus 4 is 8. So half of 7 must be between 3 and 4. Must be halfway between 3 and 4. Half of 7 must be 3.5. 3.5. Right? So 5/7 is more than half. 2/9, we know half of 8 is 4, so 2/9 has to be way less than half. 3/4, we know half of 4 is 2, so 3/4 has to be more than half. 1/6, we know half of 6 is 3, because 3 plus 3 equals 6. So if I only had 1/6, that has to be way less than 3. 4/10. This one is a little more difficult. But if I know half of 10 is 5, if I have 10 marbles and I divide them into 2 groups, into half, each group would have 5 marbles. 4 is less than the 5 marbles. So, therefore, 4/10 is less than 1/2. All right? Are we getting used to saying the fractions as well? Maybe not quite yet. Now, we're comparing fractions that do not have common denominators. So we want to kind of think about these, and we could use our heads is what we could do. We could use our heads so that we figure it out. Without any tricks, we could probably figure it out. But guess what? I know a few tricks. But let's just try and use our heads to figure these out. All right? So now we don't have common numerators or common denominators, but we still have to figure out, which often we don't. Often we do not have problems that are this easy to figure out with a common numerator or a common denominator. So very often we are trying to say, do I get more if I have 2/3 than if I have 1/4? Well, we can use our benchmark of 1/2 again. And we know that 1/2 of 4 is 2. So that's a lot less. 1/4 is a lot less than half. And 2/3 has to be more than half because it's almost as much as 3, right? What is half of 3? Well, what is half of 2? 1. What is half of 4? 2. So half of 3 must be 1.5, right? So 2 is definitely more than half of 3. And 1/4 is definitely less than half. 1 out of 4 is definitely less than 2 out of 4. So therefore, 2/3 is greater than 1/4. Let's take a look at number 2. We have 6/8 and we have 1/3. That's easy too, isn't it? Because 1/3 is less than half of 3. And 6 out of 8 is more than half of 8, right? So 6 out of 8 has to be greater than 1/2. And 1 out of 3 or 1/3 has to be less than 1/2, which means that if 6/8 is greater than 1/2, it's greater than 1/3. Because 1/3 is less than 1/2. Because remember, we just said 1.5 or 1.5 plus 1.5 equals 3. If you have 3 marbles and you want to divide them by 2 players, you'd each give each one of the players 1 marble, and then you'd have to cut the other marble in half. So each player had 1.5. If you put them all back together, you would have 3 marbles, right? I think she's lost her marbles. She really is talking a lot about these fractions in great detail. I know. 2 out of 4, we know that's 1/2. 4 out of 6 is greater than 1/2 because 3 out of 6 is equal to 1/2. So therefore, 4/6 is greater than 2/4. The next one, we're going to start moving quickly. 3/6 we know is 1/2. 5/9 is what? Well, 5 plus 5 is 10. So, and 4 plus 4 is 8. So 5/9 must be greater than 1/2. And we know that 3/6 is equal to 1/2. So this time we've got a 3/6 is less than 5/9, or you could say 5/9 is greater than 3/6, but we don't read from right to left. We read from left to right. Let's look at number 5 quickly. 1/5 is way less than 1/2. 3/10, oh my gosh, this one is really difficult to figure out. 1/5, 3/10, I know 5 is half of 10, and that's 2 below 5. I know that 2.5 is half of 5. 1 is kind of way less. I'm not exactly sure. I'm pretty sure 1/5 is less than 3/10, but I'm not 100% sure. How could I figure that one out? I'm going to show you this trick before we leave, okay? All right, so you think about it for a minute while I get the trick up here. Uh-oh. Taking me longer than I thought it was going to. I went past it because you don't have to go whatever. Okay. I know, you could have seen me going through all that, and it probably would have been worthwhile, but I didn't send you there. All right, so here we've got numerators and denominators, and we have a little trick that I'm going to leave you with, and then I'm going to show you the rest of the problems and see if maybe you could do the little trick. And this is where you want to be able to get to your multiplication tables. So let me just quick take a look at that. We're not going to do the comparing fractions. We're going to do the multiplication tables. Okay, so let's not forget that we want to be reviewing our multiplication tables, all right? So we're going to go through these charts. So you can take a look at, let's start again. We'll start with the whole table right there. So you can take a look at your multiplication tables and maybe make up some flashcards for yourself, or go spend $1.25 on flashcards, although make sure that they are complete, because the flashcards that you have at the $1.25 store or whatever, they're not full sets, all right? They've got a lot of, you could mix them up and use them, but they're not full sets. So another way to also memorize our timetables is to learn to count by that number. So if I wanted to count by, learn my timetables for 7s, I would learn how to count by 7. 7, 14, 21, 28, 35, 42, 49, 56. I'm reading now, but I could do that pretty quickly. Learn to count by them. And remember, we learn to count, first of all, by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. We can keep going, can't we? There's our timetables for 8, our multiplication tables for 8, for 9, for 10, for 11. Those are easy too. 11, 22, 33, 44, 55, 66, 77, 88, 99. Then we get a little more difficult, but since it's by 10s, we know that's easy. Add a 0 to the 11. 110, then it gets a little harder. There's our multiplication tables for 12s. And then they also have 13 and 14 available as well if you wanted them. Okay, so we want to learn our multiplication tables, although we don't really need to know them really that high to be able to do this little trick to find out, for example, is 4/6 greater than 3/5? How would we do that? Well, what we would do is we would multiply 5 times 4. And if we multiplied 5 times 4, we would know that's 20. 5, 10, 15, 20. That's 20. Then we this is called cross multiplication. Then we multiply the denominator by the numerator so that we get our numbers on the right side. And that is 18. 6 times 3 is 18. Is 20 greater than 18? Yes, it is. So 4/6 is greater than 3/5. Okay? That's how you do that. You use this cross multiplication. I'll leave that up there for a minute so that you could see how we did it. I'll go through that one more time. Multiply. I don't think I did it for the second one. 5 times 4 equals 20. 6 times 3 equals 18. 20 is greater than 18. Oh, I did it here. 20 is greater than 18. Therefore, 4/6 is greater than 3/5. Okay? All right. So if we did the same thing here with our fractions here, we would multiply 10 times 1. You don't need that to be so big now, do we? We would use 10 times 1, so we know that is equal to 10. And then we multiply 5 times 3. And when we multiply 5 times 3, we get 15. And we know that 15 is larger than 10. So that's the side that is greater than. So therefore, we know that 1/5 is less than 3/10. Okay? And that's how we do that. Cross multiplication. And then the greater, multiplying starting with the denominator times the numerator, put the number up on that side, on the numerator side. Denominator times the numerator, put that product up on the numerator side. Which one of those numbers is larger? That's the fraction that is larger. And now you can see the next one, number 6. You can figure that out. 6/8 using cross multiplication is 6/8 greater than, less than, or equal to 2/3. Number 7, 5/8. Is that greater than, less than, or equal to 3/4? 4/10. Is that greater than, less than, or equal to 2/5? 2/5. Is that greater than, less than, or equal to 5/15? 5/6. Is that greater than, less than, or equal to 2/3? 1/3. Is that greater than, less than, or equal to 2/5? 3/7. Is that greater than, less than, or equal to 3/9? 3/5. Is that greater than, less than, or equal to 1/4? 6/8. Is that greater than, less than, or equal to 3/4? 4/5. Is that greater than, less than, or equal to 6/8? 3/4. Is that greater than, less than, or equal to 5/7? And the last one, 5/8. Is that greater than, less than, or equal to 7/9? So now you have a new way of comparing fractions using a little trick that we all know, which is called cross multiplication. And you can see now why knowing your multiplication tables can really help you out in fractions. Are we done? No, we're not. We are not done. We will be continuing fractions on Tuesday after our 4 days off, because here in the classroom, we know how to spend time. We spend time working for 3 days really hard and even preparing. I'm only on here for 3 days. I spend a lot of my time preparing for the classroom. So I certainly am working more than 3 days. But those other days that I'm working, I'm doing something that I really enjoy. And I think that's what we're teaching you here in the classroom. You've got a different spirit and heart and soul and mind than I do, which means what you will bring to the world is going to be special because it's different and unique from mine. And that's how we learn from one another. This is Dr. Annette Feravich. We've gone long, but that's because it's day 200. So guess what? We'll be late coming back on. We will be here at 10:30 for the Bookless classroom, still celebrating day 200, but we'll still be reading from the American YAWP. Thanks for joining me here in the classroom on day 200. Whoop, whoop.